This video is going to go over the questions that are in the review for your test on Friday. Although I'm going to show you some ways to do these, please keep in mind that this isn't the only way. But I do, like on the multiple choice, like we talked about in class, I do want you to have an opportunity to see how we can use the calculator to help us determine our answer. Because remember, on multiple choice, you don't get any partial credit. So it doesn't matter if you show work or not. So let's look at the very first question. It says the value x equals 4 is a solution to all of the following equations except which? So the first thing we need to talk about is, what does it mean for it to be a solution? For it to be a solution, it must make the equation true. Okay. So the first thing I'm going to do is I'm going to use my calculator to figure out if x equals 4 is the solution. So if I go to my calculator, I'm going to open a new document, add a calculator page, and the first thing I'm going to do is store 4 as x. The next thing I'm going to do is type in the first equation, 2x plus 7 equals 15. If I hit enter, I see that that is true. So I'm going to put a T next to this equation. Now, they want to know it's a solution to all of the following except which. So I'm looking for a false statement. Because if it's not a solution, then it should come out false. Okay, the next one, choice 2, is 3 parentheses x plus 1 equals x plus 11. If I hit enter, darn, I get that that's true as well. So now I can try 3 and 4. So let me try 3. 3 is x plus 5 equals 3x minus 3, not negative 3, minus 3. Oh, I get that's true too. Now, you might be tempted to circle 4, but let's just make sure x plus 12 equals 5x minus 2. Oh, there it is. False. So this is my answer. 4 is not a solution. It doesn't make the equation true. Your other option for these is you could take each answer choice and you could solve each equation. So subtract 7 from both sides. You'll get 2x equals 8. Divide by 2. And I get that x equals 4. So 4 is a solution. Okay. However, it's very easy to make a mistake algebraically. So if you can use the calculator on a multiple choice, it's going to be helpful. Number 2, which of the following is the solution to this equation? Okay, so I'm going to go ahead and solve this equation, and then I'm going to show you a shortcut in the calculator. So x over 5 plus 3 equals 10. First thing I need to do is get my x over 5 alone. So I'm going to subtract 3 from both sides. That's your subtraction property of equality. X divided by 5 equals 7. Then I'm going to multiply both sides by 5. That's my multiplication property of equality, and I get x equals 35. Here's a second way that you could do this. A second way would be to use if you go to menu and go down to number 3, algebra, you're going to notice that there's something called numerical solve, number 1. You can put any equation in here as long as it's linear, and it will give you your solution. So I'm going to type in, I need a fraction first of all. So control fraction, x over 5. Now, I want you to notice that x is bold. That means it's using the stored value I had before, and this is a different problem. So I'm actually going to go to my home screen. I'm going to open a new page, and I'm not going to save this. By opening a new page, it gets rid of my stored values. So I'm going to go back to menu, algebra, numerical solve. And now I'll grab my fraction, x over 5. And notice that x is not bold anymore, so that's good. Plus 3 equals 10. And then you need to tell it what variable it's solving for. So the way you do that is by pressing this comma, which is down next to the letter O. And the variable we're solving for is x. So if we hit enter, we can see that our answer is 35. So we've got the algebra and we've got a quick way to check it in the calculator. One other way you could check it, if you got 35, you could take 35, store it as x, and then type in the equation, x over 5 plus 3 equals 10, and make sure it's true. So you've got a lot of different ways you can use your calculator to verify this. Okay, number 3, the sum of a number n and a number 5 larger than it is 41. So the sum, that means I'm going to be adding, of a number n and a number 5 larger than it. The it they're referring to is n, the number. So I'm adding two things, the sum, okay? What I'm adding is a number n, and means I'm going to the other side of my plus sign, a number 5 larger than n. Well, 5 larger than n is n plus 5, and that equals 41. Now I can go ahead and I can, it says which of the following equations could be used to solve. So I actually don't even need to solve this. Which equation could be used? Number 2. Okay, question 4. The value x equals -3 is a solution to all of the following except which? So if it's a solution, it should be true, okay? But I'm looking for the one that's false. So I'm going to say find the false one. So, okay, I'm going to take -3 and I'm going to store it as x and hit enter. And actually, anytime we're storing, let's go back and open a new page so we don't get messed up with any of the previous stored values. Okay, -3, store as x, enter. Oops, I forgot my x. There we go. Now I can type in the first problem. That negative in front of the 5 is a negative. So make sure you enter this as -5x minus 12 equals 3. And if I hit enter, I get true. So I know the first one is true when x is -3. On to number 2. X plus 1 is less than or equal to. So remember, to get those symbols, you have to do control equals, is less than or equal to 2x plus 4. Enter. Also true. Okay. Let's go on to number 3. 3x minus 4 is less than x minus 7. Enter. Oh, man. They love to make it the last answer choice on these. Okay. Let's make sure the last one is really false. Otherwise, we might have a typo here. Negative 2x minus 5 is greater than or equal to negative x plus 12. Enter. And there it is. There's the false one. Okay, so there's 1, 2, 3, and 4. We were able to do 3 of those 4 with the calculator. Okay, here's number 5. Which of the following values is a solution to this equation? Okay, so I can go ahead and solve this. First thing I'm going to do is distribute the 3 through. So 3x minus 18 equals 18. I'm going to use my addition property of equality to get the 3x alone. And then I'm going to divide both sides by 3. And I get x equals 12. It's worth taking the time to verify this. So I'm going to go ahead and open a new document. And let's use our equation solver. So go to Menu, Algebra, Numerical Solve. And I'm going to type in 3 parentheses x minus 6 close parentheses equals 18. And then tell it comma x. So it knows it's solving for x. Hit enter. I get 12. So I can be very sure that this is the correct answer. Okay, number 6. The inequality 2x plus 1 is greater than 15 will be true when x is 7, x is 0, x is 10, or x is 5. So the first thing I could do is I could do this algebraically. So for inequalities, step 1 is to find where they're equal. This is your boundary point. So when is 2x plus 1 equal to 15? So I'm going to solve this. Subtraction property of equality, division property of equality. And I got x equals 7. So my boundary is at 7. So on my number line, here's 0, here's 7. 7's my boundary point. Now, because this is just greater than and not equal to, I know I need an open circle. You need an open circle if it's greater than or less than. You need a closed circle if it's greater than or equal to or less than or equal to. And that might be something you put on your index card. So I know I need an open circle at 7. The question is, which side of 7 makes the inequality true? Do I go below 7 or above 7? So my second step is to test one side of my boundary point. So test one side of 7. So I'm going to use x equals 0 and see if it makes it true or false. So if I plug 0 in for x, so instead of 2 times x, I'm going to do 2 times 0 plus 1. I want to see, is that greater than 15? So 2 times 0 is 0. And I get 1 is greater than 15. Well, that is false. So that means 0 cannot be part of my solution. I cannot shade this direction. That means my solution is up here. Now, if you wanted to do the test point in the calculator, you can take 0 and store it as x. And then you can type the original inequality in. 2x plus 1 is greater than 15. And that's going to give you false. So you can also see 0 doesn't work. So now we've got to figure out, okay, which of these numbers is in the solution? Well, 7 is right here, but it's an open circle. So 7 is not part of the solution. 0 is not in the shaded area. So 0 is not part of the solution. 10 is up here. 10 is in the shaded area. So I think 10 is part of the solution. And then just to make sure, 5 would be somewhere here. So 5 is definitely not. Now, you could also store each of those values and then test your inequality 4 times. That's up to you. Again, there's more than one way to do many of these problems. And if you just wanted to verify it, again, I could take 10, store it as X, and then I could come back up here and grab my inequality and hit enter, and I see that it's true. So I know that the inequality is true when X is 10. Okay, number 7, the area of a triangle is given by this formula. If the equation is solved for B in terms of A and H, that means I want to get B alone. Then what will the result be? So I have A equals 1/2 BH. First thing I want to do is get rid of the 1/2. If you multiply both sides by 2, the 1/2 and the 2 cancel out. So on the left, I get 2A equals B times H. So now to get B by itself, I need to get rid of times H. To get rid of multiplication, I use division. The H's are gone. And I get B equals 2A over H. And that corresponds to choice number 1. Number 8, which of the following compound inequalities is shown by the graph below? So if I look at my solution here, I can see that my solution is in this part or this part, which means I can get rid of 1 and 2. Answer choice 1 says X is anything between -1 and 5. So that would be like in here. This one says, again, X is anything between -1 and 5. So I need to choose either 3 or 4. Well, what's the difference between these? Here's -1, and at -1, it's an open circle. Remember, an open circle means that you're using a greater than or a less than. So if I look, this says X is less than -1, and choice 4 is X is less than or equal to -1. Well, since this is an open circle, it can't be choice 4. Let me just verify at 5, it's a closed circle. So that means it's greater than or equal to. So 3 is our correct answer. Whoops. Number 9. Jenna manipulated the following equation, 4x plus 7 equals 10, by adding -7 to both sides. Which of the following properties justifies this? Well, associative property, that's a grouping where we change our grouping. So that's not it. Addition property of equality, adding the same thing to both sides. I think that's it. 3 is just where we change the order. So A plus B equals B plus A. We didn't just change the order. We added a whole new number to both sides. And then multiplication property of equality, we did not multiply. So it is choice number 2. Number 10, Ross and Chandler go to Taco Land and order sodas for a total of $3.50. They also want to order some tacos, which cost $1.75 each. If they have $20, which inequality could be used to determine how many tacos they could buy? Well, if they have $20, they can spend $20 or less. Choice 1 says that the amount that they spend, because this is the money they spend, could be more than 20. No good. Choice 2 says the same thing. The amount they spend could be greater than or equal to 20. That's no good. So now I just need to look at choices 3 and 4. So in choice 3, what they're spending is less than or equal to 20. And in choice 4, what they're spending is less than or equal to 20. The key is, does T, my variable T, which would be the number of tacos, does that go with the 350 or the 175? Well, the tacos are 175 each. So it has to be choice 4. T needs to go with the cost of each taco. Okay. Number 11 is not an equation. It's an inequality. So I cannot use the numerical solve in my calculator. Okay. We can only solve it if it's an equation. So I'm going to have to go ahead and solve this using my steps. So step 1 is to find the boundary. So where are they equal? So when is negative 2x over 3 plus 7 equal to 15? Now, that I could solve in my calculator. I'm going to check it in my calculator in a minute. I'm going to subtract 7 from both sides. 15 minus 7 is 8. I've got negative 2x divided by 3. So to get rid of a divide by 3, I'm going to multiply by 3. So that gives me negative 2x equals 24. Divide both sides by negative 2. And I get x equals negative 12. Well, this actually becomes very easy because it says the solution is which set? Well, if my boundary is negative 12, and because this inequality does not include an equals, I know it's an open circle. My solution is either going to be everything above negative 12 or everything below negative 12. I need to see where it's true. Okay, so I'm going to test 0. So I'm going to take 0 and store it as x. And now I'm going to plug in my inequality. So I need a fraction, negative 2x over 3 plus 7 is less than 15. That makes it true. So at 0, it's true, which means I want this to be my solution. I don't want my solution down here. It's false down here. So if I look at that solution is any value that is above or greater than negative 12. And that matches right here with choice 1. Once you find that boundary point, the way this problem is written, you can actually figure it out because no other inequality uses negative 12 as a boundary. And just as a super quick aside, if you want, so again, I'm going to go to my home screen. I'm going to open a new document. I'm just going to quickly review how we could solve for the boundary. If I go to menu, algebra, numerical solve, I could type in negative 2x over 3 plus 7 equals 15. And just don't forget to tell it you want to solve for x. And I can see that my answer would be when x is negative 12. So that gives you your boundary if it's a multiple choice question. Okay. Which of the following intervals is equivalent to this statement? Okay, so x is anything between negative 3 and 9. So if you have a greater than or a less than symbol, that means you use an open circle, and it means you use a parenthesis. If you have a greater than or equal to or a less than or equal to, you use a closed circle and you use a square bracket. So I know my interval is going to start at -3 with a parenthesis. So that gets me down to number 1 and 3, and it ends at 9 with a bracket. That's choice 1. Okay, which of the following is an example of the commutative property? Okay, commutative property. We talked in class. Commutative starts with CO. That should make you think change order. So I'm looking for something that's changing order. Choice 1, I've got 3x, y, and 8. 3x, y, and 8. The order did not change. That is not commutative. Number 2, 5a, -5a. And then on this side, it's a totally different number. That's not commutative. 3, 12y, 8, 8, 12y. That changed order. That's your commutative property of addition. Okay, number 14. Which compound inequality represents all real numbers that are greater than -12? So greater than -12. This means at -12, I've got to have an open circle. So I can get rid of choice 2 and choice 4. And then less than +12. If it's at less than or equal to 12, we'd have a closed circle, but because it's just less than, this is another open circle. So 3 will not work. It has to be choice 1. Let me make sure I didn't miss any problems here. Okay, 14. Here's 15. Which of the mathematical sentences has no solution? Okay, so it does ask you to show your work. The first thing I would like to do, though, is show you what it would look like in the calculator. So I'm going to go to menu. I'm going to go to algebra, numerical solve, and I'm going to enter the first one. 3 equals 1/4 x minus 24. And don't forget, tell it comma x. It wants to solve for x. The solution to this is 108. Choice 2. I'm going to go back to menu, algebra, numerical solve. 10 minus 5x equals 5 parentheses. Now, I want you to notice there's no number in front of this minus. This is not a minus sign. This is a negative. This is a minus. So when you enter this, it's negative x minus 5. Oops, wait. Minus 2. Close your parentheses, comma, x. Enter. It says no solution found. Okay, we're going to have to take a closer look at this. So it might be 2, but let's see what the other ones give us. So number 3, menu, algebra, numerical solve, -3 parentheses 2x minus 1 plus 9 equals -9x plus 8 plus 3x plus 4, comma, x. Enter. I get that there's a solution of x equals 0. Okay. And then let's look at the bottom one. 4x minus 6. So I'm going to go to menu, algebra, numerical solve. 4x minus 6 equals 9 minus 4x, comma, x. Enter. And I get x equals 1.875. So it looks like the one that has no solution is choice 2, but let's see why this is. What would this look like? So if I go to solve this one, first thing I'm going to do is distribute. So I get 10 minus 5x equals negative 5x minus 10. So now I'm going to add 5x to both sides. I end up with 10 equals negative 10 because my negative 5x and my positive 5x cancel. 10 equals negative 10 is false. Therefore, there is no solution. Now, negative 6x. Okay, I do want to look at number 3 for a minute because this one does something interesting. So let's go ahead and distribute. So we get negative 6x plus 3 plus 9 equals, on the right side, I can combine my like terms. Negative 6x plus 8 and 4 is 12. Okay, I'm going to keep combining. Negative 6x plus 3 and 9 is 12 equals negative 6x plus 12. Well, look at this. I ended up with the exact same thing on both sides. This is always true because they are exactly the same. So your calculator cannot tell you if there's infinite solutions. It told me that 0 was a solution, which it is, but 0 is not the only solution. For number 3, it's always true when we simplify it. So your solution to choice 3 would be infinite. Infinite solutions. Okay. In number 1, if you were solving this, you could add 24 to both sides. That gives us 27 equals 1/4 x. I can multiply both sides by 4, and I get 108 equals x. And that's the answer I got here. Over here, if I add 4x to both sides, I end up with 8x minus 6 equals 9. Add 6 to both sides. 8x equals 15. Divide both sides by 8. And that's how we get that answer right there. Okay. Okay, part 2 questions. Pedro and Maria each opened savings accounts on the same day, intending to withdraw the money for weekly expenses. So we're looking at 2 different people. Pedro opened his account with $710 and withdrew $35 per week. Maria opened her account with $570 and withdrew $25 per week. In how many weeks will their accounts have the same amount of money? Same equals. Okay, so Pedro, he starts with $710 in his account. He's withdrawing, which means he's subtracting $35 per week. Now, the minute you write a variable, I would go up and say, let W equal number of weeks. Do not forget your let statement. Okay, so there's Pedro. Who is the second person? Maria. She had $570 and she is withdrawing $25 per week, which means 25W. In how many weeks will their accounts have the same amount of money? So I want Pedro's 710 minus 35W to equal Maria's 570 minus 25W. So now I can go ahead and solve this. Again, more than one way to do this. I'm going to move the negative 35W by adding it. Those are gone, so I get 710 equals 570 plus 10W. Then I want to get this W by itself. So I'm going to subtract 570 from both sides. 710 minus 570 is 140. So I can divide both sides by 10, and I get 14 equals W. So what's the question want to know? In how many weeks will their accounts have the same amount of money? They will have the same amount after 10 weeks. Or at 10 weeks, either or. Now, if I want to check this in my calculator, I can go in here, algebra, numerical solve, 710 minus 35W equals 570 minus 25W. Tell it, comma, solve for W, 14. So I can see and be confident that that is my correct answer. Okay, solve the following equation for X in terms of all other variables. So solve for X. That means get X alone. So first thing I'm going to do is circle my term that has X in it. I need to get rid of the minus M because there's no X there. So I'm going to add M to both sides. So now I have Rx equals P plus M. Those are not like terms, so I cannot combine them. I just have to leave it as P plus M. The left side is R times X. So to break apart multiplication, I do division. And my answer is X equals P plus M all over R. $18. Oh, another one. I love it. Okay, so in this one, what does Q equal? So we're trying to isolate Q. So I want to get this term by itself. So the first thing I'm going to get rid of is the 16. So I'm going to subtract 16 from both sides. That leaves me with negative 1/4 Q equals R minus 16. Again, the 16 doesn't have an R, so I can't combine these. To get rid of a fraction, you can multiply by the reciprocal. So negative 4 over 1. So I'm going to multiply this side by negative 4. That gives me Q equals, we're used to seeing the number out front. And so this would be my answer. You could also write it this way. I would not write it this way because this would be incorrect. That looks like I'm subtracting 4, not multiplying by negative 4. So be very careful when you write that answer. Okay, 19, give a property of real numbers or a property of equality that justifies each step. So when I look, here's the problem that's given to me. If I look at what happened in step number 1, I notice that there's no more parentheses. I think what they did was they distributed. So my first property is distribution or distributive property. Between step 1 and step 2, what changed? Well, in step 1, I have 5x, 15, and 2x. And now I have 5x, 2x, and 15. So the order changed. So this would be the commutative property. I am not going to require you to write if it's commutative of addition or multiplication. You can just write commutative. In the third step, okay, if I look, I have 5x plus 2x. They wrote the 5 plus 2 in parentheses and the x is outside. If I were to distribute the x back in, I'd get what I started with. So this is actually distributive property, but in reverse. So because they pulled the x out, they were able to add the 5 and 2 and make it a 7x. Let's look at what happens in step 4. We had 7x plus 15. Now it's 7x plus 15 minus 15 equals 4x plus 9 minus 15. So it looks to me like they subtracted 15 from both sides. This is the subtraction property of equality. And once we do that, we get to this step right here. When I look at this step here and compare it to the step in number 5, I've got to think about what's different. So when I look at this, there's a minus 4x on both sides. So guess what? That's another subtraction property of equality. Step 6, they undistributed the x. Distributive property. And then step 7, they're multiplying both sides by 1/3. That's the multiplication property of equality. Okay. For the remainder of the test, the last couple questions, I'm going to record a separate video for those. So this is the end of part 1. Part 2 will be a separate video for you because it's the end of the day and hopefully I'll have some of you after school. Okay.